It's a little early, but if you want to get started now, we can do that.
Uh, yeah. I'm not sure. Let's wait a few minutes. I know your time is very precious, so it's it's down to you how you want to proceed.
Okay.
I think we can start because there are so many things that I'd like to ask you, and there's so little time. So I would really like to cherish what little time we have.
All right. Well, that's fine. Are you live streaming this, or are you
Yeah,
recording and playing
yeah.
it back?
I'll be live streaming on Twitch, twitch.tv. So it's more for a gaming platform, but there is a team called Live Coders. So there is like a subsection, a team that's dedicated for live coding streams, educational streams, and interviews similar to this.
Okay. All right. Well, if you've set up a specific time, I don't want to. I don't want to get ahead of that. If you were just recording it, then I'd say, well, we could record it now. But if folks are
Yeah,
expecting to join at a certain time, then we should honor that.
yeah. Let's just get to know to each other a bit. Then I'll talk
Sure.
about myself a bit. So I am not like a massively experienced software development. I software developer. I have 4 years of professional experience, and I have bachelor's degree in software engineering. So not that experienced, but I'm really passionate about clean code, and it led me to create a community where we spread that, where we teach programming with based on best practices right at the beginning. Like you're learning how you define variables, so you might as well learn how to name them properly right away. So
Okay.
that's the idea.
Cool.
Yeah.
Cool. I love to hear it.
um yeah, so I'm teaching that oh crap, a little fly on a camera.
Yeah, I saw it.
So I teach programming once or twice a week sometimes, weekly, I mean, and
And where do you teach it?
on Twitch. And I also do
Oh,
part time officially in Software Development Academy. There's this kind of institution. Yeah.
okay. Very good. And you're teaching to beginning programmers or people who aren't
Yeah.
programmers?
Uh, it's usually, well, in Software Development Academy, it's usually people who want to change their career, who want to
Ah,
become programmers. So
good
either
idea.
graduates or someone who would like to change their profession. Yeah.
Okay. Yeah, great.
And on weekends, I love teaching. Well, on weekly basis, not officially. I like teaching clean code, design patterns, design, yeah, software design, and things like that, based on various sources like multiple books and clean code especially. Uh, I recently read actually XUnit, testing patterns. It's a
Oh,
great book.
yes. Uh-huh.
Yeah,
Mhm.
I learned quite a bit from it. So yeah,
Yeah,
it's
Gerard Metsaros. That's quite a, compendium of of techniques.
yeah, it is. But as always, they're all based on uh, a set of specific rules, best practices. So it's like I like understanding the set of practices so that those techniques, not techniques, but the patterns, they flow naturally. Like I
Mm-hmm.
hate following semantics if they don't solve a problem.
Mm.
Yeah, it always needs to add value to the business. Otherwise, it's not very useful. Well,
True
why
enough.
we're doing it if it's not making our you know lives easier as developers, as business, and etc. You have a really nice setup in the background.
Oh, that's my flight simulator.
Oh,
Right. So yeah, I practice flying on that. So it's I've set it up with a really good processor and all the necessary tools, so it's very realistic, and that helps.
Do you own a plane, or you're?
Oh yeah, yeah.
Oh wow, nice.
I do. Let me see. I think I can show it to you here. Let's see if I bring up a picture of it. Let's see. La 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 la. Let's see. How do you do that? There we go. That's the pictures. Oh yeah, here's a. See, I think I can share that with you. No, I can't share anything because I'm not a host.
Oh,
You'll have to make me a host
let's
or
see.
a co-host or something.
Let's see. Participants, more, make a host. Yes, now you're a host.
Oh, now I can show you. All right, let's do that one. And I think you can see a picture. Let's see if I can bring that one up. That was me flying over Kansas, I think. Not too long. Are you seeing it?
It's wrong screen. I see the emails.
Oh, odd. Okay, let me see if I did that wrong. Bring up Zoom. Yeah, you don't want to watch my emails, do you?
Yes.
Let's see. Stop sharing. Let's do a new share.
Yeah.
Share the screen. It should be this one. Share. Good. Yes. Okay.
Yeah.
All right. So that was me flying over Kansas not too long ago. Let's see.
That's so cool.
And then, oh yeah, there's the plane.
That's so cool.
Yeah. Yeah. So yeah, it's great. I do a lot of videos. And so my daughter and I will fly to interesting places to shoot those videos.
Wow.
So yesterday we flew around Lake Michigan and went to a lighthouse that's on the eastern side of Lake Michigan, and we did a bunch of filming at this very famous old lighthouse.
Oh crap! How did you get into that hobby? Like, did you just suddenly one day wake up and feel like I want to start flying?
It's something that I've wanted to do for years and years, but I've been busy and family and everything. And then about 5 years ago, my son decided he was going to learn how to fly. And I thought, well, I can't let him do that without me doing it. So I started taking lessons, and I just pursued it after that. So came to it late in life, but it is a blast to do. I really enjoy it. It's one of the hardest things I've ever had to learn.
Right. Well, what's the hardest thing about flying? What would you say?
So the flying itself is actually very easy. The machine is remarkably simple to control. The hard part is all of the regulations and the laws and the procedures, and there's just a zillion of them. And learning how to read the charts and learning how to talk to air traffic control and learning what to do in this situation and that situation. So there's a huge cognitive load that has nothing to do with actually flying the airplane. It's all about the traffic laws and the procedures. Very, very detailed.
Right.
And then there's a whole discipline, a whole discipline to learn about how to take care of the airplane and how to step by step check everything out. Because it's not like getting into a car and just driving somewhere.
Right. Right.
It's a ton of fun. I enjoy the hell out of it.
Okay, let's start with the interview.
Yes.
So I've set it to be for roughly an hour, and maybe it can be longer. Like, the whole meeting is 1 hour and a half, just in case it takes prolonged. Like, so in reserve, if it take longer. So yeah, every question I would like that every question would be answered with no more than in 10 minutes. And based on that, we'll try to measure it.
6 questions. Okay.
So, do you have that person in the industry that you look up to, to this day? Someone very good at programming, someone that inspires you?
There are several people that I could point to that inspire me or have inspired me in the past, and I would begin with Alan Turing, just in 1936, who wrote a paper trying to solve an obscure mathematical problem, and in so doing, essentially invented our entire industry. So
Okay.
that he's a fascinating character. In some sense, he was responsible, at least in part, for winning World War II against the Germans. He was the first person, probably, to write software for an electronic stored program computer. There's some dispute about that, but if he wasn't the first, he was the second or third, and had a remarkable impact on our industry. Then we could go forward from there. There's quite a few people that really made very, very significant contributions. Edsger Dijkstra, who became a programmer in the very late 40s, and invented structured programming and just tons of very good things.
Yeah.
Of people who are currently alive today, I could name probably three people come to mind right away. One of them is Kent Beck,
Mhm.
who just had a tremendous amount of energy and insight to drive us towards the agile revolution. His notion of extreme programming and his cooperation with the whole agile movement was tremendous. His mentor is Ward Cunningham, and very few people know who Ward Cunningham is. This is the guy who invented wikis, and a whole bunch of other things. He was Kent Beck's mentor in the early days, and together the two of them invented things like pair programming and test-driven development and refactoring and so on. And then I would add one more person to that, who is Martin Fowler. Martin Fowler is a man of extremely deep insight when it comes to software things. And my favorite book of his, which is nowhere near as popular as it ought to be, is a book called Analysis Patterns that he wrote in the mid to late 90s, that every software developer should read and understand, and far too few do. So there's a few people.
Right.
I think I fit inside the 10-minute boundary there.
Yeah, I also see a book, Domain-Driven Design, so Eric Evans maybe as well.
Oh yeah, Eric Evans. Yeah, wonderful book.
Yes.
Great book. The book itself is priceless. The first half is absolutely great. The second half gets a little thick, but if you can get through it, it's certainly worth the study.
Yeah.
And this is the book that describes the one practice of extreme programming that had everyone confused, which was the metaphor practice. And we had all these practices of extreme programming, and then there was metaphor, and nobody knew how to describe it. Eric Evans describes it here.
All right. So regarding coding itself, what's the longest period of time that you had to spend, in one sitting, right? Let's say meeting a deadline. So what was your longest sitting, like of consecutively, like in one sitting writing code? And how do you prepare yourself for that?
Well, you don't want to know the answer to that. Probably something on the order of 30 hours.
Okay.
When I was young and stupid, I was young and stupid. And one of the attributes of a young and stupid programmer is to believe that if you work 30 hours for your employer, it demonstrates to them that you are dedicated.
Yeah.
And it does nothing of the kind. and it is not a good thing to do. But in my 20s, I was working for companies, and there were deadlines, and And it was impressed upon me how important those deadlines were. And I called up my family and said, I won't be home. And I wrote code for hours and hours and hours and drank lots of coffee. And by the way, the vast majority of that code had to be thrown away a week later because it was all crap.
Yeah.
It's not something you actually want to do.
Yeah.
And that's one of the reasons that in the Agile set of practices, there is a practice called sustainable pace. You
Yeah.
run at a pace that you can actually sustain long term
Yeah.
instead of these, very, very silly um, late night, overnight, overtime sessions.
Yeah.
They don't pay off and they
De-
don't work.
Definitely. So regarding those sustainable, regarding sustainable pace, uh, do you often achieve the state called the flow? You know, the like ultimate focus of a developer, and
You don't
like
want to know the answer to this question. Yes, yes. In my younger days, again, when I was young and stupid, I was young and stupid. It is possible to get into this state of hyper focus, right? And your vision literally narrows down.
yeah,
All is the screen, and you're just in the code.
yeah,
What I have discovered after years is that that is probably the worst time to program anything. The code that comes out is generally awful. Uh, the the context that the code lives within gets ignored. The period of time in which you are doing that gets ignored. Um, and so nowadays I work very hard to not get into the flow. I try to avoid the hyper focus. If I feel it coming on, I will stand up and take a break. I understand that it feels good. There are certain hormones that begin to get injected into your blood in that state, and you get a kind of state of euphoria. But it is not a good state for working through problems in a large context. It is really only good for working through small problems in a very narrow context. And in our industry, we don't have a lot of those problems. Every once in a while, there is some, really narrow thing, like you want to invent some kind of new sorting algorithm, and you lock yourself in a room and you hyper focus down there. And okay, fine. But when you're dealing with business applications and you've got customers and you've got team members around you, the worst thing you can do is hyper focus.
right. Um, so, anyways, when you write code, do you try to eliminate all the distractions? Because I've heard developers, literally taking their laptops and going to a library to focus.
Where is my tomato? I think I probably took the tomato to the office. So there is a technique that I use from time to time, which is called the tomato technique or the Pomodoro
Yes.
technique. And you can look this up. And it's very, very simple, right? You get a little kitchen timer and you set it for 20 minutes. That's the time I use, 20 minutes. And then while that timer is running, I remove all distractions. So I shut the door, I turn my phone on silent, I remove the distractions. If anybody knocks on the door, I tell them to please come back in 20 minutes or whenever the timer dings. And during that period of time, I will be writing code or working on whatever. And then when the timer dings, I get up, I leave, I walk away. This is one of the techniques to prevent the hyper focus, right? You get up, you walk away, you get a cup of coffee or you get a Coke or you go outside and smell the air. And within about 5 minutes, you come back and you start the next timer. If someone had interrupted you, that's the time you go and you address the interruption and you talk to them and they answer whatever, make some phone calls or whatever. And then after a little while, you set the timer again and you do it again. The technique is a wonderful technique. I encourage you to look it up. Pomodoro technique
Right.
was described by an Italian professor whose name is Francisco Cirello, something like that. And definitely worth investigating.
Okay. I'll look it up. So the opposite of that, when you do program, but not necessarily program, but in general, work as a software developer. So what aspect of being software development like drains you or annoys you the most? Like what is the least satisfying part of being a developer?
Okay, yes. The least satisfying part of being a developer today, for me today, is debugging. Because nowadays I look at debugging as a failure. I should not have to debug. I write tests. I write code. My tests make sure my code works. I should not be injecting any bugs. So if every once in a while I get a bug and that bug was not caught by one of my tests, and I have to go bring up a debugger and set a breakpoint, I feel very frustrated. That is the wrong
Right.
that is the wrong thing for me to have done. It means that I somehow failed. There was a time in my life when I thought debugging was the best part of programming because, I'm going to solve this problem. But nowadays I have a very different view on that. I don't want to cause the problem.
Right.
So I follow the discipline of test-driven development, which keeps me out of the debugger much more than anything else I've ever tried.
Correct me if I'm wrong, but weren't you the one who said that also debugging is a skill that programmers should be ashamed of?
The words I use are that it is not a skill to be desired.
Right.
I do not desire to be a good debugger.
Yeah.
Because the only way you become a good debugger is to do a lot of debugging.
Right. That makes sense. So if you have to debug a test, do you consider that test being too complex?
Yes. Debugging a test is it doesn't happen to me very often. Usually if there's a bug, it's not in a test. Although I do have to say from time to time, I will see a test fail and I realize that the problem is in the test and not in the code, that I stated the test incorrectly. But it's very, very seldom that I get a debugger out to debug a test. That I don't think that's happened to me in years.
Right, because they're simple enough and small,
well,
localized. Yeah.
Yeah, they need to be simple. Tests need to be, 3-4 lines. So they shouldn't have bugs in them usually.
Right. So debugging drains you the most and takes the most energy. What about communication? Well, to me personally, when client directly is involved, it's quite tiresome, to communicate directly to a client who doesn't know what they want. Nowadays, when I'm in a bigger company, that doesn't happen because you have, like, we follow Agile. There is a product owner. There's a whole layer of business people involved, and you don't really directly communicate. Do you still have to do that as a programmer?
Oh yes. Oh yes. And it is a skill that you must cultivate and get very, very good at. When I was younger, I worked at a company, and the CEO of this company was absolutely adamant that all programmers must communicate with users. Now, we were producing a system that tested telephone lines, and our users were the guys up on the telephone poles trying to repair those telephone lines. So the CEO of this company made sure that each one of us went out in the trucks with the repairmen to watch what they were doing up on the poles for a day or two.
Right.
And there is nothing more enlightening than to watch your users use your system, and you suddenly see all the hell that you have created for them.
That's true.
So absolutely, it is a skill that programmers must cultivate and develop. You should never trust that someone else can specify the system for you adequately. They're not going to write down the requirements properly. They're not going to give you the understanding that you need to write the code that actually satisfies the user. The more you can talk to the users, the more you can talk to the customers, the better.
So I'll say my experience right now, and I'd like your opinion on it. So I've been in a new job for a year. It's a big company. Like we have 3 teams, roughly 20 people working on a product. And in 1 year time, I haven't seen or spoken to the client. Like I haven't seen them use the product in any form. I've only seen business present the requirements and have some charts of the statistics, the telemetry and such. So do you consider that as being flawed fundamentally?
Yes,
Yeah.
absolutely. Now, you said it's a 3 teams and
Yes.
each team is 20 people.
No. It's roughly 6 people, 3 small teams,
Okay.
so in
All right.
total 20. Yeah.
If I were the executives running your company, I would take those teams one at a time and I would have them do a tour of whatever the customer site was. Or I would invite the customers in to talk to the teams. Something to start that communication. Because if that communication doesn't exist, then essentially the teams are working blind. It's as though, there's someone trying to describe something that they can't see, and then having the programmers create a solution for a problem that they can't see that someone else is describing for them secondhand. It's not a good approach. Something should be done to get those programmers close to the customers.
Right. Thanks for that. So in I do agree myself that it's I mean, personally, like as a single developer, it's frustrating to communicate with a client getting requirements, but I think when it becomes a team effort, that it's a shared responsibility between everyone, it's probably a different feeling. I unfortunately haven't experienced that myself yet, because it was more like a support kind of guy. When stuff is breaking, the client is calling and complaining, and you'll like have to create fixes fast. That's why that experience was kind of scarring for me in terms of client developer
At the
communication.
company I was describing earlier, where the CEO made us go ride in the trucks, when a customer called with a complaint, the people who were supposed to answer the phone were the programmers.
Right.
So we did all of the field service work in the early days of that product. We were the guys answering the phone calls when the customers called and said, my system doesn't work. It was a programmer who would answer that.
Yeah.
And we could actually get a solution real fast.
Yep. Yep. It makes sense. But the solution you would deliver, like the fix, would it, like back in the day, did you have, code reviews and stuff? Like would it still need to pass some quality check, or we would just straight push to master or even to live directly? What was
Well,
the process then?
in the days that I'm talking about, we didn't have source code control systems.
Yeah.
We didn't push anything anywhere. All the source code was on magnetic tape.
Yeah.
And the way we would solve problems is that we would dial into a remote system and patch the code in hexadecimal.
Oh God.
But we knew how to do it. We were very good at it.
Any accidents ever happened?
Well, sure. Nothing horrible. I remember one time I was actually lying on the floor in a telephone central office, reaching underneath some equipment to try and get to my keyboard, and I started a process which inadvertently started deleting rows out of a database. And if I'd allowed it to continue, it would have deleted all of them. I managed to stop it after about a minute or two and only had to recreate 1,000 or so rows. That's like the worst accident. That's happened to me on the floor of a central office.
Yeah.
Oh
Yeah.
well, I did try and strip some wires with my teeth once and found 50 volts on them. That was a good experience.
Recharging, right? Um, Slightly going back to the debugging part because we have a question from the audience about learning through debugging. Like I find it myself as well sometimes nice when you're changing code, even live running it, and in debugger just change what if this value is changed, what will happen, what if this value, like exploring the code base or the new tech, the ecosystem that you're working with. So debugging as a tool to explore that, how do you evaluate, or what's your opinion on that?
Well, there was a time that I considered that valuable, and I in 20 or 30 years ago, I would fire up a debugger. By the way, at that time, debuggers were brand new, but I would fire up a debugger and I would single step through the code to make sure that it was right. But what I've discovered over the years is that it's much better to do that with a sequence of small tests.
Mm.
If I can write these little test snippets, first of all, it's faster than single stepping through the code. Second of all, it creates a permanent record of all the little experiments that you wanted to run. And third of all, you don't need to use this separate tool which has its own problems and its own context.
Yeah.
So it actually works much better for me to just write a little test and, oh yeah, that happened. Huh? Well, what if I do this?
Yeah.
Oh, that happened. It's a much better way of learning the code from my point of view.
Yeah. So regarding TDD, I find, like, at least like half a year ago. So imagine a developer with 3.5 years experience. So writing tests first to me is okay, but when it comes to infrastructure stuff, like especially UI, web API, testing that first before writing code is significantly harder than testing business logic. And
Yes.
I would test it after, but then I ask myself, why am I doing this? And the answer is because I don't understand the infrastructure behind it. So I get the knowledge and understanding first, and then I write a test. But then I thought to myself, I'm writing code to stuff that I don't understand, so I might as well acquire that knowledge through tests instead of writing code and experimenting through something that I am aiming, to release to production. So I might as well write tests. I'm still learning in that. It's not easy, but you would say that TDD should be applied in all aspects of software, like in all parts of it. I mean, high level, low level. No.
No, there are parts of systems that are very difficult to test. There are parts of systems that are impossible to test.
Right.
And whenever you get close to the hardware boundary of the system, it just starts to get very difficult to test things, because in order to test them, you actually have to be in the real world looking at a screen, or in the real world looking at
Yes.
electrical levels or something like that. And so it's difficult. The GUI is a really good example of that.
Yeah.
When you're trying to put something on the screen, you really don't know what you want it to look like. And now maybe you've got a real hard requirements, and some person has given you absolute requirements, in which case you do know what it's going to look like. But for me, I'm putting something on the screen. I don't know what I want it to look like. So I can't write a test because I don't know what the answer is.
Right.
I don't know what the test should assert. So I will just put stuff on the screen and then look at it and go, now, and I'll fiddle with it, and I'll get the CSS out, and I'll change the fonts and the colors, and move it around. And then when it looks right, I think, oh, good. And then I don't write a test either, right? Because now I've got it on the screen and it looks right. And I am going to be putting it back on the screen many, many times in the future. So I don't feel I need a test for that. Now, all of the code that went into creating the data that I eventually put on the screen, I make sure I test the hell out of that.
Right.
So that the code that is not being tested is this really thin layer that communicates from all the decisions that I made earlier. It just kind of spits a little stuff at the screen.
Right.
And so I use that approach. That, by the way, that's one of the patterns in Gerard Metsaros's book, X-Unit Patterns. And the pattern is called the humble object.
Yes, it is.
Yeah.
Yeah. You basically extract all the logic from the UI and put it somewhere deeper, lower level.
Yes.
MVVM works with that as well, quite okay.
Yeah. It once you get used to that approach, it becomes very natural.
Yeah.
So nowadays, I'm just constantly shoving all of the logic further into the system, and I create these really thin layers that I can't test.
Yeah. Ports and adapters. It's all ports and adapters.
Yeah.
Right. What would you say is the difference between a good and a great developer?
What an interesting question that is. But I think I have an answer. A good developer can write code really, really well. A great developer has a sense of morality and ethics and discipline. I think that's the difference. You know what you are writing, you know why you are writing it, and you understand the ethics involved and your responsibility to the customer, your responsibility to the client, to your employer. You understand that you are a professional and not a laborer, that you are there because of what you know. You were hired because you know the answers to questions that your bosses don't. And so it becomes your responsibility and your moral responsibility, your ethical responsibility to inform your employers about what is possible and what is not. So an example of that is that a good programmer will be told by their boss, it's got to be done by Thursday. And the good programmer will do everything they possibly can to get it done by Thursday, including working 30 hours and all of that nonsense. And the great programmer will look at their boss and say, that's not going to happen. It's not going to be done by Thursday. I can guarantee you that it won't be done by Thursday, but here's when it could be done by. And I'm sorry, Mr. Manager, but this is a situation you are going to have to manage.
Right.
That's a great developer.
Right. Yeah. I heard stories about people's regrets. Programmer / manager people. People who do both, and actually one of those regrets was saying yes too often to the business. That was the biggest regret that developer made. Saying yes to the business. Like, you can drop a table with, let's say, 20,000 records, and that's not as severe as saying yes to the business at all times.
So there's an old adage in financial trading, which is that the most successful traders are not the ones who make the best purchases. They're the ones who get out of bad positions early.
Yeah.
Right?
Yeah.
They sell at the right time, right? They don't buy at the right time. And there's something to that in software as well. Sometimes the most important thing to say is no. Keep your company out of a bad situation instead of leading them into a bad situation.
Right.
Having done both, I prefer the no approach nowadays.
Yes. You mentioned a lot about knowing your worth, understanding what you can do, like consciously understanding that you're a professional. But the problem with a lot of developers these days is that we have a kind of syndrome, a lot of us, imposter syndrome. Have you ever experienced that yourself back in the days, or maybe even now sometimes? Does it get to you?
Wow, what an interesting question. Imposter syndrome. As a programmer, I was either fortunate or unfortunate, depending on your point of view, that I never had a mentor in the early days. You know, I had to teach myself. And there was no one with more seniority. There was no one senior to me who could teach me anything. I had to just teach myself, and therefore I made an awful lot of mistakes and screwed up an awful lot of people, and eventually learned over time what to do.
Yeah.
So as a programmer, I don't think I've ever had imposter syndrome. Now, as a pilot, which is, you know, that's something I have recently learned how to do. I have recently learned how to fly an airplane. And that was one of the most humbling experiences I have been through. And yes, there's a certain amount of imposter syndrome there with me, although I try to fight that. I don't like the idea of underselling yourself, which is what imposter syndrome is, right? I don't like the idea of underselling myself. It's just important to know your limitations. That's an old Clint Eastwood quote. Man's got to know his limitations.
Right. Right. I agree. I agree. And you said you failed a lot, and in that regard, I'm sometimes regretting teaching right away best practices. So I sometimes try to delay teaching them, but first introduce a problem and make people suffer a little bit by doing it wrong, and then showing how it's done properly, and then saying why is it better and what problem it solves. And
Yeah, I think that's a very, very powerful teaching technique.
yeah, and
Yeah.
I think the biggest problem with universities and teaching in general is that why do we have all these practices? What's the biggest problem in software development? And I think the biggest problem in software development is change. Everything is a design for change. So there is no change when you have a homework. You just do your task, you're done, happy. But you don't, you know, face the fact that requirements change. Your homework doesn't really change. So yeah, it's hard to simulate that, but I think universities and teaching in general should be based on changing, like deliberately changing stuff, so that
There
it's
are
harder.
university programs that try to do that. So in graduate level, studies, they will sometimes get a client and take on a real industrial project. And I have talked to some professors who will try to put their students through a mock project where they purposely change the requirements
Yes.
as you go along. But you are right. The vast majority of students don't really know what software is about until they get their first job, and then they
Yeah.
find that it's really surprising.
Yes.
It's not like college.
Yep. Exactly. Yep. Um.
For that reason, I sometimes think that it is better not to learn programming in a university. It might be better to learn it as a trade, in an apprenticeship, as opposed to as a science in a university program. I think you are much better learning software on the job with
Yes.
someone helping you,
Yes.
sitting next to you, pair programming with you,
Yes.
or on a team, because the hard part of programming is not learning how to write an if statement.
Yeah. That's right. So you mentioned that you didn't have a mentor, and for me, maybe a mentor isn't like absolutely critical, but to me, what critical is, and actually that's very a paradox, because people think developers are not very social, but I think community for a developer, like being a part of a community, having people to discuss ideas with, is absolutely critical for a developer, because you need to be loud and heard, and like you need to say your opinion and be wrong and understand your mistakes, and refine it over time and not be stuck with what you think is right. So did you have that community back in the days?
I did. I had a very good friend, and he and I shared similar passions. And so he and I would learn the same programming language together, and we would get jobs at the same companies together. We did that several times, and we would explore things together. And at work, we would explore things together. Then we'd come home to our homes and we would continue. We would write programs just for the joy of it, and we would compare different solutions. We learned most of basic computer science and algorithms and data structures. We learned all that stuff together through this joyous experimentation that we did over a period of several years. It was only later that there were books that we could fall back on. Back, when I was learning how to program computers, the year was like 1969, 1970. And there were hardly any books. There were books on languages. You could get a book on COBOL. You could get a book on Fortran, but not a book on how to write a program. There just weren't any of those. And then the first one I really found, and I'll bring it out here for you.
Okay.
First book I found on how to write programs was Don Knuth's Fundamental Algorithm.
Right.
Right. And yeah, I don't know if I held that up the right way, but you can probably read that. Fundamental Algorithms by Don Knuth. And to this day, I recommend these books, The Art of Computer Programming. One of the first people to put down on pages how to write basic computer programs, what the data structures are, what the algorithms are. It was later that I then discovered this book. Let's see if I can pull this one out. Yeah, there it is. This book was written in 1972, Structured Programming. And this is the book where Edsger Dijkstra, writes about maybe GoTo isn't such a good idea. And Ole Handal and Christian Nygaard write about object-oriented programming. It's a very interesting, very thin, very fascinating book. All programmers should get a copy of this and read it for the historical understanding of where these ideas came from and why.
Right.
These are the guys who paid for this knowledge with their blood.
Yeah.
They really had to work through it all. Nobody could teach them.
Yeah. Yeah, and that's the best kind of knowledge, the knowledge that is achieved through actually pain and sweat and blood. There is a question about those pictures in your background, the astronomical pictures and astronomy in general. You often bring up, you often start talks with those science facts and then slowly, gradually move towards software. So how does astronomy relate to software development, or how does the two help you?
So there is no correlation at all, except that both are technical. But as a very, very young boy, I became interested in science. Now, there are several reasons for that. One is that my father was a science teacher. So when I was very young, I would go to summer school with him and I would watch him teach the same course 6 times as the students, filed in for one period after the next. And I would see him do the experiments. He'd take a chunk of sodium metal and throw it into a vat of water and it would bubble and boil. And when you're 8 years old, that's very impressive.
Yep.
So I was very scientifically oriented very young. And space, of course, was very important to me because I grew up in the era of the Mercury space program. I was in 3rd grade when John Glenn orbited the Earth. I was in 2nd grade when Yuri Gagarin was the first man in space. I was still in high school when Neil Armstrong walked on the moon. So these things were very important to me. And so I've had a very consistent, long-term, and deep interest in all of these topics. Now, the pictures, the pictures are interesting. They have a fascinating history. I got those pictures 35 years ago, some of them are at least 35 years old, because at the company I was working for at the time, I became responsible for the very first large computer at that company. It was a PDP-11. And I was the guy who installed it. I was the guy who ran it. You know, anybody had an issue with that computer, they came to me. And I built a room at the company with 6 displays in it, 6 terminals, VT100 displays. These are one of the first video displays that programmers could use. So the CEO had said, programmers will not have these on their desks. So I built a room with 6 of them, and I got these pictures and I put them in that room. It became known as the space room. And when I left that company, they gave me the pictures to take with me. For one reason or another, maybe they didn't like the pictures. And so now they hang here.
Right. That's cool.
Long time ago, too.
Yeah. Okay. So now let's move on a bit more to the Agile part, and especially Agile during the pandemic, because Agile is, a lot of Agile is designed it to be very like personal, social, and happening physically. Like stand-ups, you literally stand up. Like you create conditions that inconveniences you not to do it, so that you don't unnecessarily spend too much time talking about what you did, and so on. So what are your thoughts on agile and pandemic relation, or in general working remotely?
Well, we have very good tools. So yes, I mean, Agile should be done together in the same room, right?
Yeah.
You really want to be able to smell each other.
Yeah.
Right. So that's the best possible environment for Agile. It's the best possible environment for any team is to be together. You want to be able to pair program. You want the customer in the room with you so you can just kind of holler over to them and say, hey, what about this? You want all that. But this is the pandemic and we have some constraints. Fortunately, we are the authors of the tools that you and I are using right now, right, to communicate halfway across the planet. Right. And we, programmers, gave the world these tools. We should be very proud of that fact. You know, we are in the midst of a pandemic, but the economic impact of that pandemic would be orders of magnitude greater were it not for us. Now, these tools are good. They're all right. I mean, I can see you, I can talk to you, we can interact, I can kind of sense your body language. You know, I cannot get eye contact with you properly. That's a problem. Right. I cannot smell you. That might not be a problem. Right? But it is still pretty good. Still pretty good. And if I've got a team of 6, I can get the 6 people on the screen with me and we can have a reasonable stand-up meeting. Not the best, but reasonable. There are good tools for pair programming. I would take advantage of those tools, you know, pair program with each other remotely, make sure you're not isolating. One of the problems with the pandemic is that it gives us an excuse not to interact with each other, and that's very dangerous. Yeah. So I would make that a fundamental discipline of the team, that there's a certain number of hours per day that we have the Zoom going or whatever tool you're using, and we are actually interacting with each other, and that a certain percentage of the code is written with pair programming. I like to say, 50% of the code should have been done with pairing.
Right. Actually, regarding pair programming, it feels like it's significantly more difficult remotely than just physically sitting next to the same screen together. Do you have any tips how to how to do it right remotely, like peer programming itself. How do you imagine good peer programming process?
Well, there's a number of techniques. Now, when you're sitting next to each other, or when you're sitting across from each other and sharing your screens, um, it's much easier, right? Because you're just closer. You can
Yeah.
interact with each other so much better. You can actually reach over and punch the guy. Right? Um, when you're doing it remotely, it requires just a little bit of extra discipline. And one of those disciplines, for example, is a game that people play, which is called ping pong. And if you're doing test-driven development and pair programming simultaneously, then it's very simple. One guy writes the test, and the next guy makes it pass. And then the first guy refactors, and then the next guy writes the test, and the next guy makes it pass, and the next guy refactors. So you bounce back and forth like that, and that keeps everyone engaged with obvious places to gain control. That's just one simple approach.
That's very interesting because usually the way I've done it is absolutely different. It's more like one guy writes code, the other guy tells what code to be written, and it's more like cooperating, but it's usually not rotating between the roles. It's like one guy does one thing, the other guy does other thing. But I think I like your approach more because it's not fair in some regard, and it's not mm, as useful, I guess.
Well, it can sometimes be an effective approach to have this navigator pilot kind of
Yeah.
relationship, right? So the one guy is busy typing and his focus is on the syntax, and the other guy is strategically thinking, like, okay, we're going to need to write this. That can be very useful, but I would let that go for about 10 minutes, half a tomato, and then switch places so that one guy doesn't just dominate one and the other guy becomes the slave.
Right. Um, I think that's clear. So, do you often get involved in the hiring process? And there is an interesting question asked by someone: if skill as a developer, if your technical knowledge would not matter, what would be the qualities that you would base if a person gets hired or not? Like, what would be the qualities of a good developer? Personal qualities, personality.
So I have hired a lot of people over the years, some good, some bad. I've made some really bad mistakes, and I've made some great choices as well. Um, and I've learned a few things about what to ask. The most important thing to do in interviewing a programmer is to sit down and write code with them.
Yep.
Make sure that make sure that they can think through a problem at the code level. And that means that you're going to have to spend a couple of hours on some problem in a pair programming session, just interacting. And if you do that, you gain a lot of insight, not just into their technical skill and their technical knowledge, but also in their ability to communicate and cooperate.
Yeah.
So that's very important. The mistakes I've made. I used to believe that you could detect a good programmer through their mathematical skill. So one of the questions I used to ask people as when I was interviewing them was I would set up a standard kind of mathematical problem, like solving the Newton-Raphson iteration or integrating the area under a parabola or something like that. And I'd want to see how they solved the problem. I wanted to measure their ability to technically and intellectually break the problem down. And that was pretty reliable until I found a guy who was mathematically very good and simply could not write a line of code. Just couldn't. And it was like, what how can you do all this math so well, but you don't understand a pointer. How can you not understand a pointer? But he could not understand pointers. We were writing a lot of C code,
Yeah.
could not understand a pointer. So there is no surrogate, and that's what I learned. There is no surrogate topic that you can use to infer that someone is a programmer. You simply have to write code with them. Now, having said that, my son founded a company, and their interview technique is one of the most rigorous I have ever heard of. You must, in order to be interviewed by this company, you must first submit a solution to a fairly significant problem. Like you have to write a tic-tac-toe solver or something like that. And they will receive that from you, and then they will do a web search to make sure you didn't copy it from some place on the web. And then they will review it and analyze it. And if they like it, then they will invite you for an interview. If you pass through the interview is the least part of this, right? If you pass through the interview, they might offer you an apprenticeship, which might be paid or it might not be paid. Either way, you are now going to go through somewhere between 3 to 6 months of indoctrination and education. They will ask you to write a web server, a functioning web server. They will ask you to give presentations on design patterns. They will ask you to write blogs and articles. And then they will put you on a tour. And that tour will be of their accomplished programmers. And you will go to customer sites and work with them. And after about 3 months of that, they will have a private vote. And the vote has to be unanimous amongst all of the mentors. And if you're unanimously elected, then you get to be part of the company.
That's insane. It sounds insane. That's the most crazy, actually, employment process I've heard.
It has the result of hiring really good people.
Well, I can imagine, but that also costs a lot of effort for the business. Yeah.
Well, so it's a trade-off. What are you going to spend your money on? Do you want to have really good people? Because those really good people are going to save you an awful lot of money make you an awful lot of money.
That's true.
Or are you going to take the risk? And okay, they opted for the expensive, but in the long run, much cheaper solution.
That's true. I think Grady Butch was the one who said it. It's like, do you want do you think good software is expensive? He asked that question, and he said, then try bad software development and tell which one is more expensive. Yeah. All right. So, in your opinion, regarding bad software developments in general, it so happens that we don't always hire perfect people, and we sometimes hire bad people. So what's the worst a developer could do? Like, what's the most damage a developer could cause being bad, simply morally as well as technically?
Well, okay. I mean, morally, that's a whole long discussion. But imagine the guys at Volkswagen who wrote the code that cheated the California EPA, Environmental Protection Agency, right? That was morally reprehensible. Now, those programmers went to jail for that, right? So programmers are going to jail now. You can be arrested and convicted for writing bad code.
Yeah.
In this case, lying and cheating code. But if you ignore the ethical side of things, I have worked with some programmers who could not write a line of code, just couldn't write the code. They would sit in their office and they would write stuff, but it wasn't code. It wouldn't execute. Couldn't compile, couldn't execute. And the rest of us would have to fix their code or actually rewrite it when they went home. And by the way, that was at a one point in my life when I was coming in on weekends, right? It was just to fix the code that somebody else had written. That happens because the interview process allowed people in that were incompetent, unable to do the job they were hired to do. There was a time in my career, a long time ago, when I thought anybody could do this. It's ones and zeros. How could you not be able to do ones and zeros? It's if statements and while loops.
Yes.
How could you not do that? There are people that cannot do it, cannot get their brains to function in that way for some reason. And I had to learn that the hard way by hiring a few of them.
It's a very interesting thing to determine the ability. Like if someone can program or not, would you say it's possible early on to capture that as a teacher, let's say, to capture a student who absolutely won't ever be a programmer?
Probably. I'm not exactly sure what the criteria would be, but it has something to do with the ability to concentrate on detail. And it's got to be the right kind of detail. It's got to be discrete detail. So an artist, someone who wants to paint a picture, they can be really focused on detail, but it's not discrete detail. It's some kind of impression detail. And they may not be very good programmers. They may not be able to think logically. And then you'll have the programmer who can think about steps in time and the way state changes in tiny little ways. And they may be very good at that, but have no clue about how to draw a picture or the shadings or the detail of some kind of piece of art. Now, one interesting fact here is that there is a strong correlation between programmers and musicians. People who tend to be good at playing an instrument also tend to be good at writing code. And I think that has to do with the fact that playing an instrument is a time sequence of logical steps, which has loops and if statements in it.
Yeah. Yep. That's a very nice observation. By the way, there's a nice, well, not a nice, but a funny programming language called Rockstar. That's all about basically making code as if it was a song, basically. Esoteric programming language. All right. Now let's move on to a slightly different topic, a bit more about testing, but testing in regards to dry principle, because often I hear from my peers, my colleagues, that dry principle doesn't really apply to tests, that you are allowed to repeat yourself in tests and it's not that bad. What's your opinion? And also in regards to different layers of tests, like, unit tests, integration tests, and so on. Like, if you have something under integration tests, would you still absolutely need to write the unit test?
So, yes, acceptance tests and unit tests. The words are wrong, right? Customer tests and programmer tests, whatever these tests are. When you're doing test-driven development, you are a programmer writing tests for yourself or for the other programmers. So I call those programmer tests. If you are a business person writing acceptance tests, I like to call those customer tests.
Yeah.
They often will test the same things.
Yeah.
But it doesn't matter because they have different audiences. The programmer tests are written by programmers for programmers, and the customer tests are written by the business for the business. And so I don't mind if they test the same things. They usually test the same things through very different approaches and through very different lengths of the system. So the programmer test will test a logical decision, but very tight in. And the customer test will sweep through the whole system to test that same decision.
Right.
So I think those are both very, very important, and I would not worry about the fact that there's any repetition in there at all.
But what about if you take programmer tests? There's still different kinds of tests as a programmer that you could write. You could mock away stuff and test something in isolation as opposed to testing something in some unison, something already wired up. For example, database is a good example. Like you can mock a database away, but that's usually a crazy decision to make, and we usually just decide to have an integration test as opposed to unit test. You have techniques to fake it somehow, not necessarily mock it. So what's your opinion on those kind of tests, programmer tests, but different kinds of tests, layers of tests?
So my rule for databases is that I want the database out of the programmer tests. I don't want them there at all. I don't want the database there at all. If I'm testing a business rule, I don't want to have to go to the database to test that business rule. So I will create an architectural boundary
Right.
that isolates my business rules from the database. And this boundary is so restrictive that above the boundary, there's no knowledge of SQL.
Yeah.
There's no knowledge of the database schema. The names of the columns and rows are not preserved.
Right.
And in fact, the structure of the database is not preserved. By the time the data gets into this layer, it's all objects that are interconnected properly rather than tables.
Right.
And then I will test my business rules up there. And there's a really hard boundary there. Right? And that's where I want my tests to go. Now, because of that, the tests are very fast because they never go out to the database, period. Right? I can the word mock is not quite the right word here. I can stub out the database very, very easily without even acknowledging that there is a database.
Yeah.
And then testing down into the database, well, that's a completely different problem. Now, all of a sudden, I can just test, okay, can I access these rows? Can I access this table stuff? Is this query stated correctly? Those become trivial tests. And the business rule tests are the interesting tests. This, of course, means that you cannot write business rules in SQL. You cannot write stored procedures for your business rules. The database has to be ignorant of the business, at least of the business rules.
Yeah.
Right. And that's the way I like to do that.
Yeah, I like to do it that way as well. Yeah, okay. So actually there's a very interesting thing recently. I'm not sure how many years already, but you've been practicing a lot of functional programming and Clojure, like you recently made lessons on that. And I was wondering, what's your opinion on object-oriented programming versus functional programming? Do you think they go hand in hand together, or that functional programming is like kind of the superior thing right now?
So there's been this idea that's been circulating around the software industry that functional programming is replacing object-oriented programming, and the two are mutually exclusive, right? If you are doing functional programming, you are not doing object-oriented programming, and if you are doing object-oriented programming, you are not doing functional programming. This is utter nonsense, absolute nonsense, right? The two things are completely orthogonal, right? You can do object-oriented programming and functional programming at the same time. Not only can you should be. Object-oriented programming is programming with, nice encapsulated data that has rules associated with it and polymorphic dispatch. And functional programming is programming without assignment statements, without mutating data. Well, you can do both of those together, and they're remarkably valuable together. So that's one of the reasons I like Clojure. Clojure is a functional language that has all of the object-oriented tools I need as well. So I can write object-oriented functional programs in Clojure.
Right. So is Clojure your favorite language to this day?
At the moment, it is my favorite language. It may be my favorite language of all time.
All right.
Really is a very, very nice language.
Do you have an opinion on C#? Because I'm a C# developer.
Opinions? Sure, I've got loads of opinions on C#. C# is a bastardized copy of Java.
Right.
That's not to say it's a bad language. It's just it was obviously stolen from Java, and then kind of migrated in its own way. There's nothing wrong with the language; it's fine. The stuff that has been done with it recently in relative terms is pretty good. You know, the query language that's been put into it and so forth. I think that's all very interesting. I also think that it is part of a family of languages that includes Java that is on the decline. So languages go in waves, and we've seen these waves come and go over the decades, right? We saw C rise and then fall, and C++ came and then it fell, and then Java came, and it's now on the downslope, and C# is on that same downslope, and Ruby came along and now it's on the downslope. And there's a whole bunch of new languages. JavaScript is on the upslope. Everybody's doing JavaScript. Yes. JavaScript is going to be everywhere, except that will probably slope down soon. And there are other languages that are trying to climb up that slope. Being a programmer long term, if you want to be a programmer for decades like I've been, then what you have to do is you've got to look at the way those languages are rising and falling. And you get on one of the upslopes early.
Yeah.
Right. And you do that by going home and playing with these languages at home and on weekends and getting smart about what's going on in the new technology, because one of those new technologies will suddenly become mainstream, and then you'll have this immense advantage. The worst thing you can do is say to yourself, oh, I'm a Java programmer. I'm going to be a Java programmer till I die, because you will follow that downslope. And you don't want to go down there.
Right. That's a really great point of view. Yep. Okay. Now the final part is about the advices and advices and mistakes. You first mentioned yeah, you mentioned already about the mistakes, so I won't ask about that. So about the advices, what's the best advice you've received over your career?
The best advice I received?
The one that stuck to you the most, maybe.
Huh. What an interesting question. This is going to sound strange. I had a boss a long time ago, and I went to that boss and I said, we need a coding standard, you know, because we were writing in C at the time, and nobody had any standard for C back then. And said, we need a coding standard. We've got to come up with a coding standard. We need a process. We need some way to get this some kind of organization and discipline. And he said the most interesting thing to me, and it's always stuck with me. He said, you're probably right, but keep in mind that it doesn't matter what the discipline is as long as everybody follows it. I was trying to advocate a particular coding standard, you know, the right coding standard. I knew the right one. And he just turned that around on me and said, yeah, no, it's probably not the right one. There probably isn't a right one. And it really doesn't matter so long as everybody follows it.
Yeah.
And that little statement there has stuck with me for a very long time, not just for coding standards, but for anything a group does, a team of developers, right? The team has to decide what their rules are, what choices they're going to make, what ethics they're going to follow, and it doesn't matter so much what those decisions are. It matters much more that they all agree.
Right.
And that they all follow those decisions together. And I always thought that was a very good way of looking at what can otherwise be a very contentious issue. Similar advice was given to me once by Kent Beck, but he stated it much more approachably. He said, any argument that lasts for more than 5 minutes is worthless and you should flip a coin.
Okay, I don't follow that.
If you cannot make your case in 5 minutes,
Right.
you have no case to make.
Right. That's true. Albert Einstein, well, not necessarily him. I'm not sure if it was him, but he said if you cannot explain something to a 6-year-old, then it means you don't understand it yourself. Right. So the last question would be about about USA and the problems there and your point of view, because someone said that there was a public outlash against you recently about and it caused an anxiety in that person about his programming beliefs, which I find strange, but maybe you have a comment. He said, I'm quoting, "My foundations are not as solid as I thought. How should I approach this issue as someone who considers you my best teacher?"
So yes, there is a culture, and it's not just in the United States. It's actually a global culture right now, which says that your political opinions and your professional opinions cannot be separated. So if you have political decisions that that you don't agree with, let's say I have political decisions that you don't agree with, then you also cannot agree with my professional opinions. So I have had a number of people take this book and throw it away because they don't agree with my political opinions. Now, that's insane.
Yes.
That is utterly insane. I may have political decisions that you don't like. I may have political opinions that you disagree with. That has nothing to do with my profession or with my technical ability or with the experience that I have learned over the last 60 years. So, that's just a very sad and sick attitude. Now, in the United States, we have a name for it. It's called the cancel culture, right? If you say something politically incorrect, then all your work must be canceled. Everything.
Yeah.
You cannot be invited to conferences anymore. I know people who have been explicitly thrown out of conferences, technical conferences, because they support the wrong political candidate.
Yeah.
That's insane. It's worse than insane. It is immoral.
Yep.
You cannot have a free society if you cannot tolerate disagreement.
I completely agree. One last thing, since we still have a little bit of time, so I would like to still use it. About if you're applying to a company, one of the FANG companies, like the big four companies, and the approach they usually take is they try to test you, as far as I know, always through whiteboarding and writing pseudocode. And I'm not sure if it's a necessity if you will be put in front of an actual computer writing actual code, but whiteboarding and pseudocoding for solving algorithms, problems that has been already been solved, or problems that don't necessarily represent actual problems that we face as developers on daily basis. So what's your opinion on those? Like, is it an accurate measurement, or like is it necessary whiteboarding in an interview process?
So when you're interviewing, many different people will do the interview. So at least that's the way we used to do it. The candidate will spend an hour with one, and then an hour with the next, and an hour with the next. Some of the people conducting the interview want to get into deep technical issues. They should be sitting down and coding with them at a real screen. Other people conducting the interview will want to get a higher level view of technical issues, at which point a whiteboard session is perfectly adequate, right? So one of the things I used to do is if I knew somebody else was going to be coding with them live, then I would take a half an hour with them and I'd say, okay, can you sketch out on the board the algorithm for the sieve of Eratosthenes for finding prime numbers? And it's just a doubly nested loop. It's a very simple algorithm, and I would describe it to them.
Okay.
If they didn't know the sieve of Eratosthenes, I would describe the algorithm, and then I would ask them to just kind of sketch it out in pseudocode. And what's remarkable about that is that about 2/3 of the candidates could not do it. So it's a great filter. If your goal is to get rid of candidates early, that's a really good filter.
All right. Thanks for that.
Sure.
So I'm done with my questions. I think you answered everything really really well, and it was a brilliant time spent. Absolutely.
That was a lot of fun.
Yeah, me too. It was really fun, and like the questions, the doubts, and you knowing you as a person is really cool. It's like I was really, to be honest, I was really afraid that you might come off slightly arrogant, but you are so simple. Yes. So simple and so down to earth, and that's
Yeah,
great.
I certainly have my arrogant side.
Maybe as a professional, I mean, just by being professionals, we might sometimes appear as arrogant. Oh, actually, yeah, there's one little thing about developers that I would like to hear your opinion. So, sometimes, actually, not sometimes, I would say often, developers, you know, have start getting a feeling of power, that they are in control, that they know a lot, superior, more than most people, which is sometimes true. But the problem with that is that they become, they look down on people. Let's say beginner asks a question and they say, oh, you don't know this thing, you're supposed to know this, don't ask stupid questions, and stuff like that. And by simply, climbing your career, you might become that, yet you have not. Do you have any advice on that? How do you not become arrogant even though you achieve a lot?
Well, it's nice of you to say that I'm not arrogant, so I won't disagree with you there. But there are principles, and one of the principles that I live by is the best way to learn is to teach. Every teaching opportunity is a way for me to learn. So I look at every ability to teach someone as benefit to me. I appreciate the ability to learn by teaching people. And by the way, that's absolutely true. The best way to learn something is to teach it. You will learn something inside and out, upside and down, every little detail,
Yes.
once you are responsible for teaching it.
Yes, that's why I do what I do.
Well, there you go.
Yes,
Okay.
I'm so glad you said
humble.
it. Yeah. I mean, it's literally the best thing to learn. I agree. I mean, you help people, and they might think you're doing a good job to them, but actually you're just really, really helping yourself.
I'm a greedy, selfish guy. I want all the knowledge.
Yes, by sharing and teaching. Yes. Wow. I'm so happy that you said that, because that's literally something that I said word by word, the same thing. That's great. All right. Would you like to share your maybe contacts, references to media or something like that?
Oh, you can find me on cleancoder.com. Just the two words, clean coder, all lowercase, all, the drill.
Yeah.
You can also see the videos that I do on cleancoders.com. That's just the plural of cleancoder.com. And my email address is unclebob@cleancoder.com. So you can send me email there if you want to. My email is crazy, of course, because I give my email address out. So you may not get an answer right away, but nevertheless, you can try and send an email. That might work. Beyond that, don't think I have any other. Oh, my Twitter handle is Uncle Bob Martin. Yeah, Uncle Bob Martin. So at Uncle Bob Martin.
Right. Do people write emails to you about architectural questions? You know, like how do you solve this problem? Like we have this problem,
All the time.
and you happily answer it?
If I can. If they write me a 50-page document, I really won't. I won't be able to do that. But if they can boil the question down to something that I can approach within 10 minutes, yeah, I'm happy to answer it. But then there are a number of people that I've developed a correspondence with over the years. That's good for my business. So, why wouldn't I do that?
Right. I think that is it. Like
All right.
that's all I have for you. Thank you a ton.
Well,
It was
thank
a
you. This has
great
been a lot
time.
of fun for me. I certainly appreciate you asking me all these questions.
Yep, it's a lot of fun to me as well. All right, I'll let you do what you want now. So see you. Take
All
care.
right. Bye-bye.
Bye. All right, it's done. I'm so happy. Holy crap. That was a great interview, and I think it was absolutely amazing. Amazing from all points of view. Personally, fun, useful as a professional. Absolute gem. I loved it, and I hope you loved it as well, as much as I did. Wow. I will try to make more of those, just for like, I will try, because I didn't expect someone, someone so big, so great would respond. And they did. So I'll try more of this and see what I can get. All right, guys, thank you for your time as well. I saw someone donated, so thank you for that a lot. I will come back to you as well. I appreciate for everything. And see you. See you next time. I'll try to do it sometime next month, maybe, depending on who I can get. Bye.